So what is a function? If you remember from last section, we talked about ordered pairs, x comma y. If we think of the x values as being the input, and then wherefore the y value as being the output, we plug in an x and get out a y. Then a function is basically a relation that for each input there's exactly one output. In other words, if you take the same x and put it into a function over and over again, you'll always get the same corresponding value of y each time. It will not change. The x is what's known as the independent variable since it denotes the inputs, and the y is called the dependent variable since it denotes the outputs. Symbolically, we can write it like this. The output equals a function of the input, or y equals f of x. Y is a function of x. That is how we would read this. Please note that f and x are not being multiplied. F is not a variable unto itself, but it describes a specific relationship between the two variables x and y. That leads us to our further discussion of domain and range. Your domain then becomes the set of all possible inputs of the function, and the range is the set of all the corresponding outputs from the function. So I can now define my function in terms of domain and range. A function is a relation that takes each element of the domain and matches it with exactly one element in the range. Examples of functions. Well, let's look at a simple one. A plane flies at a cruising rate of 550 miles per hour for 4 hours. We'll let y be the number of miles the plane travels and x be the number of hours. Then we have an equation, y equals 550x. This is a function, since for each value of x, another each hour that we plug in, there's a single corresponding value of y, in other words, the distance the plane has traveled, that we get out. Thus, we can write our equation y equals f of x, or f of x equals 550x. Please realize we're simplifying this. We're not worrying about taking off and landing, just the cruising speed and time. So we look at this function, we ask what is the domain of the function. Remember, the domain is all the numbers of x to plug in that make sense. Well, since we're plugging in x to be a time, it does not make sense to plug in a negative number. We're also told that it cruises at that speed for up to 4 hours. Therefore, our domain should be all x between 0 and 4 hours. Now for each domain, each element of the domain, there's a corresponding element of the range. And then that makes sense that the range is going to be increasing as time goes on. So what we need to do is take the endpoints of our domain and figure out what the corresponding range values would be, or what the y values would be. So f of 0 would be 0 because f of x is 550x. So 550 times 0 is simply 0. F of 4 is 2200 because 550 times 4 is 2200. Thus the range, not the domain there, the range would be 0 less than or equal to y less than or equal to 2200. We can also evaluate our functions. If I were to ask you to evaluate f of 3 and tell me what it means, f of 3, whenever we put a number into the function, whenever we do on the left-hand side, we do on the right-hand side as well. So f of 3, we replace the x with 3 on the left, so we will replace the x with 3 on the right. F of 3 is 550 times 3, which is 1650. And this simply means, according to our function, that after 3 hours, our input, the plane has flown 1650 miles at its cruising speed, which is the output. Question is, how can we identify if a relation is a function or not? Let's look at an example. We're given the function y equals x squared minus 8. Is y a function of x? In other words, if given some value of y, is there exactly one corresponding value, given some value of x, is there just one corresponding value of y? In this case, yes. If we pick some arbitrary value, say x is 5, whenever we plug x into our equation, we get 25 minus 8, which is 17. And every time we plug in that x value, we're going to get out that 17, that y value. So therefore, for every value of x, there is just one value of y we get out. Let's look at another example. Given x equals y squared, is y a function of x? In other words, if given a value of x, is there just one corresponding value of y? In this case, the answer is no. Because if I pick a value of x, say 16, there are two possible values of y which would work. Y could be 4 or y could be negative 4, because 16 equals 4 squared and 16 equals negative 4 squared. So therefore, there is not a unique value of y for given value of x. This last example is a bit tricky because we're going to use something very similar. It says given x equals y squared, is x a function of y? In other words, if given a value of y, is there just one corresponding value of x? Notice the question is kind of backwards here. I did not ask is y a function of x, I asked is x a function of y. So therefore, we're reversing it. We're using y as the input and x as the output. And the answer here is actually yes. Because if my y is my input, I take a value of y, say 7, and when I plug in 7 for y, I always get out 49 for x. So for every value of y, there's a unique single value of x which comes out. We want to talk about the 5 methods used to represent a function. Now, typically, we only really study 4 in mathematics because we do not really worry about verbally how to represent it. And typically in math, when we start dealing with calculations and problems, we're only going to use these bottom 3, the numerical or the tabular table format, the symbolic format, which is just your equation, and then graphically or the graph. The first one we want to look at is verbally. Y equals f of x equals 550x. This is our airplane example. The distance you travel at the cruising rate of 550 miles per hour depends on the amount of time you spend at that rate. That is verbally how you would describe this relationship. If you wanted to look at tabularly how you would describe it, you would look at a set of tables, your inputs and your outputs in 2 separate columns. Now, we know x goes between 0 and 4, however, this is not a discrete function. In other words, it doesn't just have values for 0, 1, 2, 3, and 4. Notice I left question marks here. This would be an infinite table if I were to put in every possible point. I could ask for half an hour, 15 minutes, 0.1 hour, 0.01 hours. So in this case, please understand that I am limited by space and time. I could not fill this in completely. But please understand I can represent a function using a table. Input is typically your left column, the output being your right column. Similarly, I can also do a diagram. This is what's called a Venn diagram. We saw this in the previous section. We started talking about the sets of numbers. Diagrammatically, the Venn diagram maps your domain in the left onto your range on the right. Again, I'm using a discrete number, not a continuous. I'm using a limited number, in this case 5 different numbers from the set, although there's infinitely many over here, and I'm mapping them to their specific corresponding y value. Now, one of the more common ones you're going to use is symbolically, which we've already seen. Y equals f of x equals 550x. I apologize for typing in these 550s, but they're there now. And this gives us our function. We will be using this a lot as we start evaluating things. And the last thing we're going to use is a graph. And when we do graphs, what happens is our input is usually it's always on our x-axis, our horizontal axis, and our output is on our y-axis. A lot of times we'll label these. We would write x in hours and y in miles.